Okay, welcome to example 13. We have two blocks, a red block and a blue block. We'll call red block block A and the blue block block B. And they're in contact with each other, and there's an external force of 84 newtons acting on the red block from its left side. And we have given here the larger block, mass A, is 20 kilograms. And the blue block, the smaller mass, is only 1 kilogram. Okay, so what we want to do is find the contact force. And to find the contact force, we really need to treat each of these bodies separately. So, first step, draw a free body diagram. So let's do that. Okay, on block A, we have a normal force. We can call that Fn1. And we have a force of gravity, Fg1, which is equal to m1 times g. We have that pushing force, F pushing it to the right, and there is a force pushing it back. A lot of people tend to forget that, but it's touching B and B is pushing it back. So that would be to the left. That's the force of B onto A. So I'm just going to label that as force BA. That's force of B onto A. Then we look at block B. We have again a normal force, Fn2, and a force of gravity, Fg2. And we have a force pushing it to the right, and this is force of A onto B. And hopefully you'll realize that the force of A onto B and force of B onto A, these two forces are the same. They're really Newton's third law forces. They're action-reaction forces, never found on the same body. They're found on different bodies, but they're equal and opposite. So, what we'll do is we look at both of them, and hopefully you realize this is accelerating to the right, and the body A is accelerating to the right with the same acceleration. So we want to find the contact force. The easiest one is to work with B, but the problem is you don't know the acceleration. So you could solve this as a system. That might be one way to do it. You could look at this as a system like this and say there's really just one force acting on it, which is the 84 newtons acting on that system. And you could say, well, the sum of the forces on the system equals the total combined mass, mass 1 plus mass 2, times the acceleration, and there is really only one force acting on it, that 84 Newton force, which is resulting in a net force of m1 plus m2 times A. So you have 84 newtons equals 21 kilograms, that's 20 plus 1 here, times A. And that will result in, go ahead and calculate that, and get an acceleration of 4 meters per second squared. And then once you have that, then you can just look at either one of the bodies, body A or body B. I think body B looks like it's easiest because you really want the force of A onto B or the force of B onto A. They're the same thing. So let's write the sum of the forces in the x direction equals mass of body B times the acceleration, and the only force that's causing B to move to the right, accelerate to the right, is the force of A onto B, which is equal to mass B times the acceleration A. And so you could just substitute in here. You have 1 kilogram times 4 meters per second squared, which gives you an answer of 4 newtons. Now there are other ways. You could do the sum of the forces in the x here and have F minus FB onto A equals the mass of A times its acceleration, and then you could solve the two equations and two unknowns and solve it. Or you could use this method as well. So there's a variety of methods of solving this problem. Okay, that's it for this one.